Hello students, welcome to my YouTube channel. In this video lecture, we are going to look at the next 10 questions from sample paper number 7, BALI navigation book. So let's start. Question number 21. Document 10085 is what document? So, document 10085 is ETOPS, Extended Diversion Time Operations Manual. Okay, so you are going to select that option, ETOPS option. Extended Diversion EDTO, time operations. Okay, next. What determines the maximum and minimum range of a pulsed radar? So remember, you can watch my videos on radar that I have made from Oxford, Keith Williams, BALI. In that, I have explained this concept in detail. So the maximum range of a radar is proportional to pulse recurrence frequency. Minimum range of a radar depends on pulse width. Pulse width. Okay, so the correct answer is maximum range is pulse repetition time, okay, or pulse recurrence frequency, and minimum range is pulse width. So option A. Question 23. Which error causes hunting in an ADF? Postal error, night effect, static interference, and precipitation. So hunting effect is caused by static interference and precipitation. Static. So precipitation static is generated by collision of water droplets and ice crystals with aircraft. It causes a reduction in the signal to noise ratio, which affects the accuracy of bearings and can, in extreme circumstances, completely mask the incoming signal. The indications on the RMI RBI will be a wandering needle. Wandering needle means fluctuating needle, and the audio will have a background hiss, which is also likely to be present on VHF frequencies. Global navigation satellite maximum error is due to ephemeris error, ionosphere propagation error, multipath reception. So it is due to ionospheric propagation error which slows down the signals. 25. How does the forward CG affect your aircraft in terms of stall, range, and endurance? Now let's say this is your aircraft. Okay. Now the manufacturer of this aircraft will determine the forward limit, the aft limit within which the center of gravity can safely move. Center of gravity can move. Now when the center of gravity is at its forward limit, the nose of aircraft will become heavy. The nose of aircraft will become heavy like this. Okay, so the center of gravity is at its forward position. The center of gravity weight will act downwards, pulling the nose of aircraft down. So you will require extra control inputs to maneuver your aircraft. Okay, since your aircraft is nose heavy, the will decrease. Range will decrease. Okay, and stall speed of your aircraft will increase. Stall speed of your aircraft increases. So that means now you are at a higher risk of achieving or attaining stall condition. So increased stall angle, decreased range and endurance, decreased stall angle, decreased range, decreased endurance, decreased stall angle but increased range and endurance. So correct answer is option A. Stall angle gets increased, stall speed increases, range is decreased, endurance, fuel available also decreases much faster. 26. What is the indication of a VSI over a cold front? So you are flying in a cold front, in a cold air mass, cold temperatures. So a vertical speed indicator shows the rate of climb or descent of aircraft. When aircraft passes over a cold front, it typically encounters rising air due to dense cold air forcing the warm air upward, right? In a cold front, what will happen? This cold air, say this is your ground surface, this cold air will lift the warm air upward, correct? Will displace this warm air upwards. Okay, it typically encounters this warm air that will lift upward, that will get lifted upwards, uh, will create an upward movement of air, that is upward air currents, causing aircraft to experience a positive climb or to experience updrafts. So as a result, the VSI will show a positive climb rate, a rate of climb. Next, deviation is not zero in a VOR. What do we follow? Now, VOR radials or VOR bearings are magnetic in direction. We all know that the magnetic compass in your aircraft will behave completely different from the magnetic compass outside your aircraft, because the magnetic compass in your aircraft is influenced by local electrical fields, and therefore the final direction shown by your aircraft magnetic compass will be a little bit different than the direction shown by magnetic compass, an ordinary magnetic compass outside your aircraft. This difference between magnetic direction and compass direction, the direction shown by our aircraft magnetic compass, is called deviation. Is called deviation. Now, when deviation is 0 degree, that deviation is 0 degree, magnetic direction will be equal to your compass direction. That means the VOR radius that you will be following will be magnetic as well as compass. Okay, so deviation is not zero in a VOR. Now, in the question it's given, deviation is not zero. That means there is deviation is 1, 2, 3, whatever number, but not zero. Any value more than zero. So that if there is deviation, that means magnetic direction is different from compass direction. Okay, so you will be following what track? You will be following a compass track. Okay, so the final result, the final bearing or the radial or the track you will be following from the VOR station will be a compass track. The track according to the direction shown by a magnetic compass in your aircraft. Okay. What number of passengers? So number of passengers are not known, unknown to you before the flight plan at the time of filing the flight plan. So in this scenario, what will you enter in your flight plan? Okay, item number 19. So the number that you enter is passengers to be notified. Okay, so if you are unaware or the actual number of passengers that are going to board your aircraft is unknown to you at the time of filing your flight plan, you're going to enter passenger slash Tango Bravo November to be notified in your flight plan. Aircraft maximum takeoff mass is given, and a maximum structural takeoff mass is given by the manufacturer. On that particular day that you are going to fly, the performance limited takeoff mass is equal to 1,30,000. Maximum structural takeoff mass is 1,40,000. What should be entered in the wake turbulence category? So you have three different types of categories under wake turbulence: light, medium, heavy. These wake turbulence categories are specified with respect to the maximum structural takeoff mass. Okay, maximum structural takeoff mass. So a light wake turbulence category will be when the maximum takeoff mass of aircraft is less than or equal to 7,000 kilograms. Medium wake turbulence category when the maximum takeoff mass of aircraft is between 7,000 kilogram and 1,36,000 kilogram. Heavy category maximum takeoff mass more equal to or more than 1,36,000 kilogram, and super is Airbus A380. So over here the maximum structural takeoff mass is 1,40,000. 1,40,000 is more than 1,36,000 kg. So the wake turbulence category that you are going to select will be heavy wake turbulence category. Fuel in an aircraft is 14,000 pound. Reserve fuel needed at landing is 2,000. Fuel flow per engine is 1,000 pound per hour. So for twin engines, it will be 2,000 pound per hour. As is 180 knots. Find distance to PNR. Distance to PNR equals to endurance into outbound speed into homebound speed divided by outbound plus homebound, right? So let's say this is your point A departure, this is your point B destination. You're going from point A to point B, this is your point of no return. Now, departing from A, okay, departing from A, true airspeed of your aircraft will be 180 knots. Homebound speed will also be equal to 180 knots. Now, you are getting a wind component of minus 45 knots. That means you are getting a headwind of 45 knots. So your ground speed will be equal to 180 minus 45, which is equal to what? 135 knots. Going homebound, your ground speed will be 180 plus 45 tailwind, right? That is equal to 225 knots. Endurance. Endurance equals to total fuel minus reserve fuel divided by fuel consumption. So total fuel is 14,000, reserve fuel is 2,000. Fuel consumption rate, it's a twin engine aircraft, so fuel consumption will be 1,000 pounds multiplied by 2. So 2,000 pounds per hour. So endurance will be 14,000 minus 2,000, 12,000 divided by 2,000, that is 6 hours. Substitute the values. 6 into outbound speed 135, homebound speed 25 divided by 135 plus 225, 360. Numerator 6 into 135 into 225, 182,250. That is equal to 506 nautical miles. So distance to PNR is 506 nautical miles. So this concludes our lecture. I hope you have understood all the 10 questions I answered in this video lecture. Best of luck. Keep practicing these questions again and again till you gain confidence, proficiency. If you have any questions or doubts, let me know in the comment box. See you in my next video in which I will be solving the next 10 questions.